So here it is Windmill CodingKata. I've been doing this off camera, so I don't know if I should. Well, I'll explain it quickly. This is the part of the algorithm that must run, as I think. So first there's an entry, a function receive a list of points in a coordinate system. The points are as follows. We're gonna do with the example of this kata to see if we get the right one, because even the permutation is like so. And then we recognize the point that moving line collides with first. If y-axis represents the north, then calculate the azimuth. All azimuths above that should be put through. Alright, so the part 3 is reshape the coordinate system so that the hit point becomes the center of the coordinate system, and repeat that until success. Now let's do that. So we have to do that for each one, so we might prefer making a Python script that does that for us. Yeah. So if y-axis represents the north, then calculate the azimuth. Now how do we calculate the azimuth? That's we did it in the previous video. It has to do with points. So so if this is like y-axis, you know, it's switched. So if like we look at that, we must recognize this angle and this ABC, you know, ABC thing going on. We need to find the A. So I think we only need, like, let's see, the trigonometric functions, angle theta, images. Yeah, that's Firefox. Oh, whatever, man. We do, yeah, we got a J. Oh, so that's flipped. Yeah, it's like that. No, fuck, it's yeah, it's a bit. So adjacent and opposite. Adjacent and opposite. Opposite, adjacent, adjacent, opposite. So we got tangents. Tangents with opposite and adjacent. So we always do adjacent and opposite of the tangents. So we say for this one, yeah, I should really draw a little bit. Isn't that right? I'm drawing again. Let's get a new document. So this is the thing. We don't need a circle. We just have a point. So that's a triangle. We are interested in this angle. Is that possible? You can quickly find out. This angle by the adjacent and opposite. This by the adjacent and opposite. Adjacent, opposite, and so we say this is alpha or theta. It was used theta over there. So we do opposite with adjacent. We do opposite with adjacent. All right. So we do opposite with adjacent. So we do opposite, the length of course, divided by adjacent should be, well, is, not should be. I guess in math we gotta say is, because we believe whatever was discovered up until that point. We say tangents alpha. And to get to know alpha from tangents alpha, I think we use I think we use the Python modules, global modules, or is the math module? Math comp, return the number of ways to choose kitons without repetition and without order. Ah, this kind of rings a bell about another kata. It's too much for now, you know. gotta keep on track. Arctangents of x in radians. The result is between pi divided by 2 and pi 2. Alright. A10 yx in radians. The vector is in the plane from the origin to point, makes this angle with positive x-axis. The point of A10 is that the signs of both inputs are known to it, so it can compute the correct quadrant of for the angle. A10-1 and A10-1 are both correct. Okay. Because it's pi, it needs to be, I guess, in degrees. So, let's see. Tangents visualization. Let's see. Okay, cookies. Overview, tangent space. Next one. That really doesn't look like it should be on the first Google results page. Visualizing elementary calculus. ArcSec. I guess we got it. Tangent, math. Not looking for this. Oh, I'm looking for this one. So this in radius. And it starts from here. Circle. It goes from here. I guess that's 1. Also that's 1. I think that's something. So so those are like the parts of the thing. And I guess the tangents is this line, I guess. So plus or minus really doesn't matter, because this one is the same as that one. So you just say tangents absolute. So we would say, for example, if we were at the point clear, and we do Python 3. So we are at the point, what's it called? A is at, or x and y is at 2 and 1, right? Is it 2, 1? 2, 1, exactly. So if it's open like that, then the green one should be 2 and the black one should be 1. Let's see, up. This is because it's adjacent divided by, so I say from math import A10, I don't know, say A10, what is this, undefined, that's undefined. Oh, and it goes in that way. Alright. So we say of A10 of... it's undefined at 90%. Okay, so that's a trouble, you know. The good thing about sinus is that it is not undefined. It is not undefined. Just a sec. Right. The quest for visualization continues. So if we say tangents of x divided by y, or just like, let's do tangent x, it looks like that. Now why does it look like that? It goes into infinity. It goes, this tangent thing goes into infinity, but we're interested in sinus x. So that looks like that. It goes from 1 to -1, you know. That's the thing. That's the point. And if we say sinus of x, yeah, fuck. It's really hard to look at this from a different angle. Right now you see me here struggling with the basic one. I'll do Khan Academy, man. Alright, yeah, so here we have unit, right triangles and trigonometry. So ratios, so you got ratios in right triangles. Introduction to trigonometric ratios. Solving for a side in a right triangle using the trigonometric ratios. Solving for an angle in a right triangle using the trigonometric ratios. Sine and cosine of well, I guess I could go to over here, or maybe to over here, to quiz 2, to solve that, to understand that. So yeah, that's this one. And the next, fuck, come on. This thing is just not usable, man. Fucking buttons, bro. Right triangles, trigonometry. I've got trigonometric functions. There's non-right triangles in trigonometry. So yeah, we got those three trigonometric functions, which are quite plenty. So let's see. But I have always wanted to. So yeah, that will be our next day's task, to go through that, to be able to solve that one. Thank you for watching. Have a good one.